Here we go again. Proof of volume of tetrahedron. Why do I want to do this? Because I saw this on the homework and I thought this is pretty interesting for those who doesn't have a very good three-dimensional view as I do. Because I'm horrible at three-dimensional views. Anyway, let's get started. First, what is a tetrahedron? Tetra, we know it's four, right? So it's four-sided. Four-sided what? So it's that you have this solid. It's four-sided. Each of the side is in triangle. So you can think of it's four-sided with a base of a triangle. So it's three sides and a base. The base is in triangle and three other sides are triangles. This is the front view. This is the view from the front. The dotted line is the one you couldn't see, but they really exist. You can just kind of like use your three-dimensional thing. See, the dot view from that is one side, this front is one side, the dot view from the base is one side, and the two solid line with that right there is the other side. It's four side, and it's four side. Let's say this is the height of the tetrahedron. We're gonna use it later, but you can see this is the height. And the base. And the base view has a side length with an A and B. And in this case, A and B are a right triangle. Maybe because of bad drawing, they might not look like a right triangle. But when you see this thing in 3D, it's actually a right triangle. It's like you have a corner of box over here. If you don't understand it, I do a base view on that. This is the view from the bottom. So if you look at on just the base of this tetrahedron, you will see a right triangle just like that, followed by lane A and the other lane of B. And this is a right triangle. Let me make a notation on that. Just make sure you understand this. This is the right triangle. And why do we need that? Because right triangle, we all know the formula for right triangle is just height times the length times 1/2, which is 1/2 A times B, right? We don't need that at this moment, but you will see. So same thing, we want to find the volume. How do we find the volume? Use calculus. We just take the definite integral of one little solid with the volume, the area times dx. So let's say we're taking this one. Let me use the other color of the pen so you can see better which one we're actually taking. So right now, we're trying to cut it. We want to cut this out. We want to cut just a piece. We want to cut a piece of this tetrahedron. So how do we say this? What is the piece? So because we couldn't see from the back side, this is the piece we're cutting out. This is the piece we're trying to cut out. More like this. We're cutting a piece, and this piece has the same triangle property, has the same angle property as this piece. It makes sense, right? It's like you're doing a cylinder. Whenever you cut from the base, you cut one piece from the base. It's just gonna be what? It's just gonna be the base, just be a circle of that. So let's make this a solid, and this solid with the lane. Sorry, I was one hand holding camera, so the lane with A1. This is A1. A1. Oh my god. A1. Right, this is lane A1, and this is the lane. Right here, the pink one is B1. B1. And what do we know about this? This triangle with lane A1 and B1 has the same property with the triangle lane A and B. So how will we do that? Let's say we take the triangle out. So it's like this. It's smaller, I think. So it's saying it's smaller A1, because you know the size is always smaller when you cut from a smaller piece. This is the length of B1. Okay, cool enough. So yeah. And this is not just a triangle, it's actually a solid. But when we say it's a triangle first, because when we're doing the depth of this triangle, we know the depth is gonna be super small. It's like this. This is the solid of the triangle with only dx. What does it mean, the depth of dx? That means it's infinity small. We have this area with infinity small. So it's just basically the area times dx, right? So these two, they're similar. These two are similar. The triangle is similar. But the base one just bigger than the top one, right? Cool. So what do we need? First, we know the area, we know the volume of this thing now. Let's see. Like what I said, this is a right triangle. It is a right triangle, right? Because they are similar, so they must be a right triangle to be similar. And this is the area, A1 times B1 times 1/2. This is the area of this triangle. And to find the volume of it, we just times dx, right? Because we have the area and is how many, or like how tall this area is. The dx is the tallness of this volume, this solid. Think about this. It's a solid with infinity thin. It's like a triangle shape of paper, but paper is too thin, right? We call the thinness dx. And how do we find A1 and B1 now? See, there are two similar triangles. As I say, use the similar triangle theorem. Okay, so which is nice. I wrote down for you guys. Because I borrowed this one from the media reservation, so it's pretty good. So this saying, if you have a triangle A, side B, and side C, is similar to the triangle side little a, side little b, and side little c. They are similar, which means their angles are all the same. That's the similar property. Therefore, side A, this side over side B, side A over B, like their proportional is the same. They're side proportional. What that means is the same side from the similar triangle divided by the same side of the same triangle is the same. Like this, side AB over side A over side B equals side little a, side little b. And this happens all the time. You can do it a different way, like side big A divided by side big C, and that's the same thing as the side little a divided by side little c. And you can even do side CB, that's similar to the other side CB, right? If you don't understand this, you can try to Google search it, or you can just replay the video of this like infinity many times. Okay, good enough. Let's see. So side AB is side little a little b. And how do we find it? Good question. How do we find it? Now we use the H. So for instance, let me get the other color pen. You guys can have the view of this same triangle. So I have a different color pen now. So we say the distance, the height from the big triangle base to the little triangle base, this is x. This thing is x, and that thing is h. So what is this? What is that? That's just h minus x, right? So the height of this three-dimensional thing at this right here is just h minus x. And why do we need that? Because we're gonna need it. No, because we do need it. So right here is h minus x, right? You can have a view on that h minus x. And this is another triangle. This big triangle is actually with the side h and side b, if we view with the side view. And the other triangle is a side h and side a from the other side view, right? Same thing as h minus x. So what are we gonna say about these triangles? First we start with the B side, okay? So from here and here, this is pretty straightforward. It's two solid lines. It's the triangle formed by H and B. So if we use the side B, right here, we use B. Oh wow, this marker sucks. B divided by H. B divided by H. It's what? Right? B divided by H. B divided by H. It's the same meter as what? As B1 divided by H minus X, right? Yes. So it's the same thing as B1 divided by H minus X. Right? This is legit, right? So what is B1? We just use multiple property. We times H minus X each side. Therefore, I just use one color. So B over H times H minus X equal B1. And we see that why? Because we times H minus X on both sides. Therefore, we get off. We isolate B1. And same thing as A. So A is right here. The A is inside, but you can see A with this side H over X, A1 and H minus X, they are still a triangle just from the back. Maybe you don't have a view on that, but you can see the A and the H, they are a triangle. So same thing, A over H. That's equal to A1. Oops, wrong color pen. This is equal to A1 over H minus X. If you don't understand from now on, you can go back to re-watching this process and maybe pause on the video, then you can have a better understanding of how do I get this number. And that's the same thing. We times H over X on both sides. Then what we have is A over H times H minus X on both sides. That's just gonna be A1, right? That's A1. Clearly, understand, right? From the same triangle theorem. And now we're gonna solve this entire jelly thing into this one. This is the volume of one slice of the triangle, and you have infinite number of slices stacked together to form that tetrahedron. We just plug in the equation. So A1 times B1 times 1/2. And how are we gonna do that? So A1, what's A1? A1, that's 1 over H times H minus X times B1 times B over H times H minus X times 1/2. And we want to find the value of the big thing, the entire big thing. So we take the definite integral from 0 to H, because H is the height, right? H is how many definite integral we have stacked together. From 0 to H dx, because this whole thing right here, this entire thing right here, it's just saying, what it's saying is the same thing as this one from the integral of 0 to x. This is 0 to h, I'm sorry. You can check out by just doing yourself, substitute this equation into it, you will get this one. And now let's make this equation simpler. So it's 0 to the h 1/2 a times b times h square times h minus x squared to the dx. They are the same thing, right? And keep in mind again, this a over b of h squared is just going to be a constant times this entire equation. And now let's simplify it a little bit further. That is just gonna be 1/2 a times b divided by h squared. And what's h minus x squared? For your formula, right? This is integral from 0 to h. And for your formula, we got h squared minus 2hx plus x squared dx. You should remember by now, just because you learned this in algebra. I wish. And now let's take the integral of this. This is pretty straightforward, right? Just take the antiderivative of this. And this is gonna reduce to h squared x. Why? It's because the constant. Take an antiderivative of a constant is a constant times x. Minus 2h, this is a 2 right here. 2h x squared over 2. Which over 2 we put right here, and it cancel out, so it's just hx squared. Plus x cubed over 3. The entire formula we times by 1/2 a b h squared, because it's a constant, we move it down just like that, and from h to 0. And we know if we plug in 0 into this equation, it's just gonna be 0 minus 0 plus 0, which does not make sense, which is just 0. We don't have to do it. And we just plug in h. Now, if you plug in h for this equation right here, you will have h to the third minus h to the third plus h to the third over 3. And, right, plug in h for x, h squared for x squared. So this cancel out, we move down the constants, a times b over h squared. And that's just gonna be a times b over h squared times h to the third plus over 3. So, and we can reduce this term, since, let me erase it, just wipe it out, we don't need this one anymore, so let's reduce h over third h2 to 1, and this one is h. So what we have finally is only h over third times a times b over 1 times 1/2. Right? This is our final answer. What does this mean? That means you have a tetrahedron. You have you can see right here, a times b over 2. That's the square of that's the area of base of a triangle. So that means you have the area base of a triangle times 1/3 of the height, times 1/3 of its height. Just like this, we have the height, we have the base. The area of this a times b base times 1/3 of the height. That's how you get the volume of a tetrahedron. I hope you enjoy this intuition. I think the video quality is much better. Let me take an overview so you can see, and pause here for a second to see how I get a step. I use different color to do different things, so I think it's more easier to understand. And if you want to see the triangle similar formula, there is it. Hope you enjoy. Bye bye.